So when we're moving in uniform circular motion, we're moving at constant speed in a circle. The tangential velocity doesn't change. So what's happening along the radial axis, the one pointing towards the center? So what's the definition of acceleration? Think back when we first went over acceleration. We said it was either change in speed, change in direction, or change in both speed and direction at the same time. Well, if we're said that it's constant speed when you're moving in a circle, then we have no change in speed. So therefore we have no change in speed and direction. The only thing we have is change in direction. If we have a change in direction because we're moving in a circle, then we must have an acceleration. That's the definition of acceleration. So there must be an acceleration when you're moving in a circular path. Centripetal acceleration, the symbol is a little c. And the units is the same as acceleration in for all accelerations, right? Centripetal means center seeking, and it's the one that points along the radial axis. It always points towards the center of the circle, as if you were drawing the radius from the outside of the circle to the inside, to the center. It can never equal 0. If it does equal 0, it means that you're moving in a straight line and that you are not moving in a circular path. So whenever you're moving in a circle, you must have centripetal acceleration. The equation for centripetal acceleration is tangential velocity squared divided by the radius, right? You may not use the linear equation that we have for acceleration, which is delta v over delta t. The reason for that is because when you're moving in a circle, velocity is the same, right? The speed doesn't change. So your change in speed is always going to be 0, which doesn't make sense. So in order to calculate acceleration on the radial axis, you must only use this equation.